I'm Elaine Engst, and I'm a member of the Executive Council of CAPE, the Cornell Academics and Professors Emeriti Group. On behalf of CAPE, I'd like to welcome our friends and colleagues here in the Kendall Auditorium, as well as those of you joining us on Zoom. And right now, we're very hybrid. Before introducing today's speaker, I want to extend CAPE's sincere appreciation to Kendall for making this venue available for the lecture series. Their hospitality not only includes substantial AV support, thank you so much, but also free parking. And if anybody has tried to park at Cornell lately, you know what a problem that is. And the delicious refreshments for those attending in person. We'd also, of course, like to thank Melissa Rookledge, always CAPE's very able administrator, who is providing support for those on Zoom and for this hybrid performance. Those of you on Zoom are encouraged to submit questions during or just after the lecture in the Q&A box, which Melissa will be moderating. The speaker will take questions from both the in-person and Zoom audiences after the lecture. So we will go through the lecture and then there'll be questions. Those of you in the room, please make sure cell phones are silenced or on vibrate. For those with hearing aids, the auditorium now has an induction loop. So if your hearing aids have a telecoil setting, not all do, turn the setting to T, and then the sound from the microphone should come directly to your hearing aids. Try it and let people know how it works. Now turning to our speaker, it's my pleasure to introduce to you virtually in person, Zoe Lerner Ponterio. Zoe has been the manager of Cornell's very nicely acronymed SPIF, the Spacecraft Planetary Image Facility, for 6 years. I don't know whether the acronym came first or the words came first. Outreach coordination and K-12 education support are a large part of her job, and though these efforts reach thousands of people per year. She has spent half of the last 20 years working in science and public outreach on NASA's missions, and the other half teaching high school math and physics. In her current position, she works closely with schools, communities, and nonprofit organizations across the central New York region, coordinating and facilitating numerous public engagement programs. She also assists college students and planetary researchers in finding and analyzing the images sent back from spacecraft exploring our solar system. So without further ado, from me here in person to Zoe on Zoom, let's hear what she has to say. Thank you.
All right, thank you very much for that wonderful introduction. And thank you to everyone there for being here. And thank you to the AV team and CAPE for allowing me to give this virtually. I really do wish I was there in person, but health and safety first, and we have this technology, and it's wonderful that we can do this now. So today's talk that I'm going to be giving is called Shooting the Moon, and it has a double meaning because this talk is about the history of photographing, or at least trying to capture, the moon. But also the phrase "to shoot for the moon" means, according to Webster's dictionary, to try to do or get something that is very difficult to do or get. And that is a theme that runs throughout this talk as well. And so we're going to take a trip through the past. We're going to tell some interesting stories. We're going to solve a few mysteries. And we're going to start quite long ago. So pens, let me get my pointer here to work. Of course, it doesn't work now. There we go. We're going to start tens of thousands of years ago. The moon is one of the things that has been a part of humanity as long as we have had the human species around. It's one of the most notable things in the sky. And even in these ancient cave paintings, we see lots of series of dots, and many of these dots end up being in patterns that seem to be an attempt to track the lunar cycles, in association probably with timekeeping, the coming and going of herds, and just all facets of life. So this has been a long time fascination with trying to record what the moon is doing in our skies. Fast forwarding to about the year 1600, here was one of the best maps of the moon of the day, drawn without a telescope, let's remember, by William Gilberton. So the theme throughout this talk is that we're going to have a progress of a certain technology. Things are going to get better and better. And then a new technology is going to come around and things are suddenly going to jump and get horrible. And that's just the way that things go with a new technology. Is it doesn't always make a leap in the better direction. It often takes a huge step backward. Now, when we invented the telescope, this is one of those things that did take a big step forward. In fact, these were sketches of the moon done in about 1609 by Galileo with a 1.6-inch telescope, which gave him about a 3 times magnification. So he was, among many things, quite the accomplished artist. And we can see that this is a vast improvement upon making a map of the moon without a telescope. So for the next few hundred years, telescopes improved incredibly. So this is 225 years later, we have this 1834 edition of the best map of the moon that was available at the time. It's actually a 12-part map, and we can even appreciate the detail by zooming in on one little quadrant. So again, remember, this is hand-drawn by people looking through telescopes. But this is 1834, and we are about to take a huge leap forward in technology and leap back in quality because we are about to invent photography. And so that happened just a few years after this map was published. And so I tried to find one of the key things of this talk, the first ever photograph taken of the moon. And it turned out that this is not an easy thing to track down, because in searching through different history sites on the internet, I actually found what seemed to be different images being credited as being the first ever photograph of the moon. It's important to realize that it only took a little over a year between the very first photograph that was taken and the first photograph of the moon. And so it is very notable that one of the first things somebody thought to do with this new technology of the photograph was to point it through a telescope to look at the moon. So here is one of the images that I found that claimed to be the first photograph of the moon. Again, this is pretty awful looking. That is perfectly valid. And I'll tell you, when I first saw it, it took me a long time to figure out what even I was looking at here. And I'll bring my pointer over here. I at first thought that this maybe was a reverse, that this was an inverse, and that this black crescent shape was the moon. Then I was like, well, what are these blotches? Those aren't craters, obviously. Come to find out, those were damage to the original photograph. And then it took me a while before I realized that no, this dark area is the dark sky. The larger circle here is the telescope view, and this is the moon inside here at about quarter phase. So the half illuminated moon that's not quite centered in the telescope view. So this was taken by John Draper on March 26, 1840. He reported apparently that he captured the moon on January 2nd of the previous year, 1839, but didn't show it to anybody because apparently it was very out of focus and not great. He basically like, yeah, it's a photographic plate with the moon's image on it, but it's nothing that I want to show off to people. So basically what had happened was he announced that he had done this at 26th on March 26th. This was shortly after this huge meeting, but there's the problem. The meeting happened on March 23rd, where he announced he had this photograph. And yet, according to these records, this image was taken on March 26th. So why did he announce that he had the image and then take the image 3 days later? Mystery. I found another reference that claimed this was the first ever photograph of the moon. And this one was attributed to March 23rd, which was the day that he made the announcement. And that announcement was to the New York Academy of Sciences. So which one is the real one? Well, staring at these long enough, I suddenly realized something, that if we reorient things a bit and stare long enough, I realized that these are the same photograph, actually. And one of them is a very damaged copy, and the other one is possibly a restored version. I was never actually able to get a very straight answer to whether it was just a better preserved version of it or someone had done a digital restoration on it. Never got a clear answer. But if you look long enough at these two images, you'll start to see, like, yep, that is definitely the same image. But this still remains the question of, did he take this on March 23rd, which was the day that he announced it, or did he take it 3 days later on March 26th, which would be rather odd? Well, I suddenly thought of a good way to answer this question, and that's the phase of the moon, right? We know exactly the phase of the moon on every single date. We can run the numbers in either toward the past or future. This is clearly a quarter moon phase. So I looked up to see what phase the moon was in on those two different days. And on March 23rd, it was not in a quarter phase. It was in a waning gibbous. That means that the gibbous is when most of the moon is illuminated and it's getting less illuminated. And indeed, 3 days later on March 26th, the moon was in a quarter phase. So that pretty much nails it, that this was taken March 26th, 1840. Interestingly, 3 days after he announced that he had successfully taken an image. Perhaps there was an image that he took before March 23rd and he was going to show it, and then he decided it wasn't good enough and decided to try again. Seems to be lost to history exactly what happened, but he definitely seems to be the first person to take a photograph of the moon, and started with it through a telescope, because a regular photograph would have just shown a bright dot in the sky. Now, very quickly, he got better at this, and so this is a picture that he took later that same year. So late in 1840, he managed to capture the full moon, and yes, that is a much better image. So he continued to perfect his technique, keeping in mind the length at which you'd have to expose this picture is long enough that the moon has moved in the sky, and he would literally sit there with a hand cranking it at just the same speed so that it stayed lined up with the moon while he was exposing the camera. So really impressive work on his part. His son continued his work, and this was a picture taken by his son on September 3rd, 1863. So this is 23 years later. His son was getting even better at it. So now we're going to kind of travel forward in time and say, how did photography progress? This was taken sometime in the 1950s by the Mount Wilson telescope. At that time, it was one of the largest optical telescopes in the world, a 100-inch wide mirror. And so we were able to see more and more detail. Though again, this photograph does not really rival that hand-drawn map, but we were able to actually capture photographs at that level of detail. And of course, in the 1950s, something else was happening, the dawn of the space age. And we were getting on the edge of sending the first spacecraft to the moon. And so we're on that cusp of seeing the moon up close, which means, yes, we are about to take another enormous leap back in quality and look at the very first image taken of the moon up close. At least up close as in having traveled to the moon and being in orbit around the moon. And this was taken by the Luna 1 spacecraft. That was a Soviet spacecraft, first one to reach the moon and return an image on January 4th, 1959. So that's only 119 years later after the first ever photograph taken of the moon. This next image was taken by the Luna 3 spacecraft later that same year, and it is notable because this was the first ever photograph, the first ever view of the far side of the moon. Let's keep in mind, we always see from Earth the same side of the moon. It is what we call tidally locked, which means it rotates at the exact same rate that it orbits. And therefore, it's like two people holding hands and spinning around in a dance. They're both spinning, but they always are facing each other. Now, in this case, the Earth is spinning and does not always face the same to the moon, but we get the idea. But let's just take a moment to appreciate the fact that this was the first time any human had seen this side of the moon. And immediately, even based on this very low quality image, it was evident that the far side of the moon was quite different than the near side of the moon. We did not see those vast mare, those darker regions, those darker, smoother regions. In fact, the far side of the moon turned out to look much older than the near side of the moon. Now, this image we have to put in here because I work for NASA, and so this is NASA's first image up close at the moon, taken by Ranger 7. They were 5 years behind. This was taken July 31st, 1964, at 9:09 a.m. Eastern Daylight Time, to be specific. Now, this spacecraft job was not to just go around the moon. They actually were they wanted to get really close, and so its goal was to crash into the moon and take images on the way down. This was about 17 minutes before it hit the surface, and it was one of a series of 4,317 images that it took on its way down, being one of the first. And this was the last of that series, taken 2.3 seconds before it impacted the surface. The smallest features you can see in this image are only 0.5 meter wide, so 1.5 feet wide. So this becomes now humanity's first ever really up close view of the surface of the moon, seeing that it looked very smooth with very smooth craters sitting on the surface. This location that it crashed, it was named Mare Cognitum, which is Latin for the sea that has become known. So we commemorated this first ever time that we saw the surface of the moon quite up close from a distance that a person would see it if they were just about to land. Now, the first ever spacecraft to successfully attempt a soft landing was in February 1966, and we're back to the Soviet program because they, in the beginning, were a little ahead of us, and this was the Luna 9 lander. So its job was to actually not crash into the moon, but land on the moon and return data, including, yes, photographs from the surface of the moon. Now, the plan was that it would land, and if we look up here, this looks like a boxing punching bag, is basically the first time we were going to use an airbag technology to basically cushion a landing. And if you know anything about spacecraft and even Cornell, you will know that we used to land things on Mars by surrounding them in airbags. We landed the Pathfinder mission and both the Spirit and Opportunity rovers by inflating airbags all around them to cushion and bounce as they went. So then the next plan was that after it rolled to a successful landing, it would open up and start taking data. We, of course, were not, I wouldn't say spying, but I mean, it's sending out radio signals, and anyone on Earth with a radio dish can pick up those signals. You can't classify and only send them to one location in the Soviet Union. So, of course, everyone was listening in. But the problem is, of course, that the radio signals are encoded, which made it a little difficult to know exactly what we were receiving. But you could still track the spacecraft's motion. Also, keep in mind that we knew nothing about this system of landing that would cushion things. And so as we watched this spacecraft, we measured that it hit the surface at 13 miles an hour. That's not terribly fast, but if you're in a car crash at that fast, that's not nothing. And so they concluded very quickly that it had been a failed mission and it had crashed into the surface. Except then it started sending back data. And so they were like, wait a second, it's alive. We're getting something from it. So that was a little surprising. They didn't know how they pulled that off. And they were picking up a signal that was very clearly an image. But again, they didn't know exactly how it was encoding the image. But that didn't stop them. And they said, you know what, we're going to process this, and we're going to take the best guess. And one of the things that they really did not know was the aspect ratio. They didn't know how it was coding height and width of the image. But they decided, wouldn't it be great if we released that image before the Soviet Union had a chance to? And so the folks at Jodrell Bank Observatory did exactly that. And before the Soviet Union had a chance to share that image with the world, they shared this. Yeah, it was a little bit of a gut punch. And immediately people were like, whoa, that looks so strange. And they were noticing how seemed to be these clumps that were sticking up really high out of the surface. And the surface looked very rough and jagged, and that looked very interesting. And at that time, there had been several people with different theories as to what the surface of the moon was actually like. And what was interesting to watch was how they reacted to this photograph so quickly. So, for instance, Gerald Kuiper looked at this and said, oh, wow, well, I had said that the moon would be covered in bare, dust-free bedrock, and that's exactly what this looks like. I have been vindicated. Hal Mazursky at the United States Geological Survey had said that it should be more like a surface of jagged lava flow, like we would see in the Hawaiian Islands. And he claimed this image totally justified his theory that that's what we were looking at. So everyone kind of jumped on and tried to claim that this indeed supported their theory. Tommy Gold at Cornell even got into it. He had said that it would be strewn with rocks and fine-grained dust, and he said, yep, that's exactly what this image shows. So it was a very amusing thing. Everyone saw what they wanted to see in this image. Now, Hal Mazursky was being interviewed about this, and an eager reporter, when he mentioned the Hawaii-type lava flows, said, wait, the surface is volcanic? Isn't that where we sometimes find gold on Earth? And without really thinking about what he was saying, because sometimes scientists don't have the best in media training, he kind of went, oh, yeah, that's true. And of course, the headline then was, oh my gosh, we found gold on the moon, which no, we did not. Well, a few days after this flurry of excitement, the Soviet Union finally got around to releasing the image, and it turned out that they had guessed wrong on the aspect ratio. So this is the correctly processed version of that. And, just that little change in processing, it looked a lot less weird, and it was a lot more like, oh, those are just regular rocks sitting on the surface. The surface doesn't look nearly as rough. And still there was disagreement. There were no dust bowls, there was no bare bedrock, it was not quicksand that it immediately sunk into, as some people had said, no veins of gold, obviously. So everyone was kind of a little disappointed that it wasn't quite as exciting as they originally had thought. At this point, we get into an era where we start actually sending missions to orbit the moon. And that inevitably leads to a desire to take a look back home. And so the next thing in our journey is indeed the first ever image that was taken of the Earth from the orbit of the moon. And this was taken by the NASA Luna Orbiter 1, August 23rd, 1966. And it was on its 16th orbit. And if you look at this photo, you're like, yep, it's grainy. It's all, kind of rough. It got those streaks on it and all this stuff. And you're like, yeah, well, it was early technology. It's what I expect out of an image. But turns out actually that this was only one of two cameras. And this was the one that was meant to capture a wide angle, low resolution, easy to quick send back to Earth just to let them know everything is working image. Imagery at that time was actually pretty spectacular because the other more sophisticated camera took that image. And so actually we have to give them quite a bit of credit. They were taking images that honestly hold up quite well against some of today's images of the Earth and the moon. So things were progressing quickly. One of the things that people ask is, we take for granted now that we take pictures digitally. And that means that we can then beam them right back to Earth with radio waves. But this was long before the invention of digital cameras, CCD cameras. And that's actually pretty new technology. I remember when I got to college, and one of the things that had just happened at my college, this was 1996, was we had finally gotten the CCD camera for our campus's telescope. Yeah, so it wasn't that long ago. NASA was using before then, but not back in the 60s. So it begs the question, how in the world do you get images radioed down in digital format that weren't taken digitally? A common thing that was done back then was to not actually take pictures, but to send a television camera on board the spacecraft and use the same technology that we were using at that time to do live television broadcasts. In other words, no image was actually being taken. You were basically getting a very choppy TV video back from your spacecraft. And no actual image was ever recorded and stored on board the spacecraft. But this one, Lunar Orbiter 1, didn't do that. So this was basically one of the first actual photographs taken in space. It had a camera on board that actually had film and actually took an image, and then had a scanner that would on board develop the film, the negative film, and then scan that film to measure where it was dark and light, transfer that into a digital signal, and beam it back to Earth. So it had an onboard darkroom and an automated image development lab, which, you know, pretty awesome. So yeah, you could take a perfectly old-fashioned film picture in space and then turn it into a digital signal that you could send back. So now we get to humans actually going to the moon, and for the first time, not some automated system taking pictures, but actual people with cameras taking pictures. And you might have seen this very famous image taken in December of 1968 by Apollo 8, the first spacecraft to carry humans around the moon and back. And the story goes that if you listen to the recording and the transcript, the astronauts on board were Frank Borman, Bill Anders, and Jim Lovell. And Frank Borman is heard saying, "Oh my God, look at that picture over there. There's the Earth coming up. Wow, is that pretty?" And Bill Anders, keep in mind, Frank Borman was a veteran astronaut at that point. Bill Anders was a rookie. This was his first mission. And Bill Anders responded, "Hey, don't take that. It's not scheduled." Because you see, there was only so much film that they brought with them, and their mission was to prospect the surface of the moon for landing sites. And so therefore, they had a strict schedule of images that they were supposed to take of the surface of the Earth. So he's sorry, the surface of the moon. So he's responding with the like, don't waste a single picture on something that's not on that schedule. And so Borman told the story over and over again about how he managed to convince them to take this. And Borman said, quote, that when I wanted to take a picture of the Earth as it came over the horizon, he objected. "Gee, Frankie said, that's not in our photo plan. Eventually, I was able to talk him into giving me the camera so I could take pictures of the Earth over the lunar landscape." Those are Borman's exact words in an interview with Life magazine in 1969. After there's something a bit wrong and off about that story. And the immediate thing that strikes anyone who knows the personalities of the astronauts might know that Frank Borman was probably one of the only humans to go in space and not experience what's known as the overview effect. He very much saw this as just another job. And he went up there very no nonsense and just didn't really ever seem to have that awe about what he was doing. He was just like, yeah, that's a thing we did. And suddenly you're like, wait, that doesn't fit his personality, with him being the one taken like, whoa, oh my gosh, look at that pretty picture. And a rookie astronaut who's just like, oh my gosh, this is amazing, is the one who's like, no, that's not scheduled. And so investigator years later decided to look into whether or not Borman's story checked out. And there's actually a slightly earlier image taken in black and white because they had both black and white film and color film. They had more black and white film, of course, because it was less expensive. And so there were only very choice images that were scheduled to be taken in color. Well, this journalist interviewed Bill Anders, who kind of said, yeah, it was the other way around, but I didn't want to make a fuss over it when I heard the Borman took credit for it. And this journalist didn't just read the transcript, he went back and actually listened to them. And after interviewing both men, he clearly could tell their voices apart. And it turned out that indeed, no, it was Bill Anders who wanted to take a picture, and it was Frank Borman, in true Frank Borman fashion, who was like, no, it's not on the schedule. When Frank Borman was confronted about this, he was like, I must have remembered wrong. And I was just joking with him. And then he explained that he probably got confused because apparently earlier, Bill Borman had wanted to take a tourist photo of something on the moon. And Bill, being a rookie, had been like, no, don't take that. And so Frank was like, oh, well, that's what I'm remembering. And I was just like, getting him back jokingly for having said that. So this kind of unraveled very quickly about Frank having taken credit for this photo. Now, this first image was taken, by all accounts we can figure out, by Bill Anders, actually. But then where does the color image come from? Well, after he took that grayscale, he was like, well, but the Earth is this beautiful blue thing. It needs a color image. Well, Jim Lovell had the color camera. And so then he and Anders proceeded to argue over who was going to take this picture because they were looking out two different windows and arguing over who had the best view and the best shot. And apparently this got kind of a heated discussion, a bit of argument. Finally, Lovell conceded that he'd hand Bill the camera, and so Bill also took this color image. So we finally know who took this, and kind of a bit of drama with figuring that out. And for that reason, if you look at all future images taken by the Apollo astronauts, they're all just credited to the crew. And so that was probably a wise thing to do on their part. This was the first ever movie taken of an Earthrise, and this was taken from Apollo 10's crew. So that last mission that didn't quite land, they did everything except land. They descended in the lunar lander, and at the last second said nope and backed off. And that's what they were supposed to do. They were supposed to test every single step of the mission except the landing. Now, this is a view that you will never see from the surface of the moon, because let's remember, the moon always faces the Earth in the same direction, which means if you're on the moon, wherever you are on the moon, the Earth is a certain position in your sky and it never changes. So this is an Earthrise is only something you can see orbiting the moon. And of course, the next big leap forward was actually landing on the moon and getting our first ever pictures taken by a human on the surface of the moon. And this leads to a whole series of images where I can basically say everything is the first for something. So this was the first ever picture taken by an astronaut on the moon, taken by Neil Armstrong. This is the first ever picture of another person taken from the surface of the moon, also by Armstrong. This is the first ever picture taken of a person standing on the moon, taken by Armstrong. This is the first ever picture of the Earth taken by a person standing on the moon. This one was taken by Aldrin, actually. This is the first ever picture of that famous boot print, an actual, human footprint on the moon. And this, of that mission, was the first ever and one of the few ever pictures that is so iconic that you can see both astronauts. This was taken by Neil Armstrong looking at Aldrin, and you can see the reflection of Armstrong in Aldrin's visor that he has down because bright sunlight. This is the only picture out of 122 pictures Apollo 11 took that is Neil Armstrong, not in a reflection, turned out most of those images that you heard were taken by Armstrong. He was the photographer on board, and this is the only one that Aldrin took of Neil standing on the surface. So that's it. That's the only picture we have of Neil Armstrong on the moon, with the exception of the live TV broadcast and some of those images, but an actual photograph, this is it. Now, this is a photograph of a camera. That weird looking thing in the lower left is actually a camera. It's a camera that was designed to be pointed at the surface of the moon to take very up close images of the moon. In fact, two cameras in there, so they were stereo images that could be viewed in 3D. And this is a pitch for one thing that's cool about coming to visit SPIF, which is that we have one of these. Now, that one that we have did not go to the moon. The ones that went to the moon and landed there were left on the surface of the moon, because why bring back a camera that you know everything about when you can bring back moon rocks that you don't know anything about? So yeah, most of their equipment was left on the moon to make as much room as possible for bringing back lunar samples. This particular one that SPIF has, though, is not just a model. It actually was scheduled to fly on Apollo 15. Unfortunately, it was cut out in favor of a different experiment, but Apollo 11, 12, and 14 all used their cameras on the surface of the moon. I actually think that Apollo 13 was probably in the command module that was jettisoned before landing. So either it's floating out through space somewhere or burned up on reentry in Earth's atmosphere. But we do have one here, and you can hold it and you can check it out. Now, as things continue to progress, we have sent many, many missions to the moon, and NASA's not the only space agency. So this is actually a real-time movie taken by the Kaguya spacecraft, which is a Japanese spacecraft, on November 7th in 2007. This is also orbiting, just coming over the south pole of the moon, which is notable because that is where we are planning to land Artemis astronauts over the next few years and establish a permanent lunar base. So we are still taking these Earthrise movies. Just absolutely fascinates us to see that Earth rising over the horizon. NASA's big claim to lunar photography over the last over 10 years now has been the Lunar Reconnaissance Orbiter. Using this, we have mapped literally every square inch of the moon, both in visual and terrain models 3D. And one of the things I love about a lot of the images that LRO has taken is that it doesn't just take images looking straight down. It orbits very low to the moon because there's no atmosphere to worry about, and takes a lot of these angled images that just make it seem more real. You can see the 3D nature of things, these fresh craters that expose lighter material. This one is honestly one of my favorite images, where it's not only taken at an angle, but also at a low sun angle, and that's the central peak in a crater. To give you a sense of scale, the boulders on top of that peak are about house-sized. Now, LRO has also made some amazing science discoveries with those equally cool images, including these pictures of collapsed lava tubes. This could be great for humans because you're exposed to radiation on the moon because of being outside of Earth's magnetosphere and no atmosphere. So establishing permanent bases possibly inside these old lava tubes would offer some radiation protection. Now, you might have heard that the moon's surface is very old and the moon has not been geologically active for billions of years. A lot of people were putting the last massive volcanic activity on the moon as being anywhere from 2 to 3 billion years ago. However, recent discoveries have called that into question. In this image, that bluish color is real, and that is titanium dioxide. And the explanation for what it's doing there is actually extremely recent volcanic activity. This evidence would put that at only 100 million years ago. So that's very different. That's 1,000 times sooner than 2 or 3 billion years ago. So we are still discovering things about the moon. Now, as we move beyond lunar missions and we start to even back away and leave the Earth-Moon system, we start to get spectacular images that have both the Earth and the Moon in them. Now, if you search first image of both the Earth and Moon, you oftentimes don't get this image. You get an image taken by Voyager 1 in, what was it, launched 1977. But again, kind of digging into things, I found that that's not necessarily an accurate attribution. This image was taken in 1966 by an Earth-based satellite that, well, if you're in orbit around the Earth, you can see the Moon if you're at the right angle. And the misattribution happened because the whole Earth isn't in this image. So that Voyager 1 image taken 11 years later was indeed the first image that caught the entire Earth and Moon in one image. But yes, this was taken 22,300 miles from the Earth, and the Moon was on the opposite side, so it's small because it's 270,000 miles away. This image was indeed taken by Voyager 1. So this is that 1977 image. It's really spectacular because you've got both of them in crescent. So it is really this idea that you are leaving. Voyager 1 and 2 were leaving to the outer solar system. So they're looking back on the Earth from that nighttime side. One of the things, though, about this image is that the Moon has actually been processed differently than the Earth. The Moon's brightness has been bumped up because it turns out that the Moon is actually noticeably darker than the Earth. And they wanted to balance that so that they looked more similar in brightness. This is an image taken from NASA's Deep Space Climate Observatory. And this image shows you a more accurate view of, again, that very odd looking far side of the Moon that's just not the one we ever see from Earth, and how dark it is in comparison to the disk of the Earth. Now, this spacecraft sits at about 1 million miles away from the Earth in the direction of the sun. Its goal is, again, to look at global climate and always be able to image the entire Earth in full phase and sunlight all at once. But it also takes some pretty cool movies of the Moon passing between the Earth and the spacecraft. So this was taken in July of 2015, but we are now going to start to really venture a little further out. And the final part of this talk is about how far can we get away and still see the Earth and Moon separately. So this was a picture taken in 1992 by the Galileo spacecraft as it left on its final pass by the Earth before heading out to Jupiter. And this was taken from a distance of 6.2 million kilometers away. So pretty spectacular cameras on board. The Moon is actually in the foreground. So the Moon's actually closer to the spacecraft than the Earth. And so that's why it looks a little bigger than in those other images. But when you capture both the Earth and the Moon in an image at once, the problem is this creates a false sense of how close together the objects actually are. When they're close together and lining up in their orbits, it's easier to get them both. But this was a series of images taken by the Juno spacecraft in 2013, as it also left on its way out to Jupiter. And we can see it's actually moving. You can see the Earth changing in size as it's moving on its way to the Earth for a pass. And we see the Moon actually moving as well. And even that bottom image is not the full distance between the Earth and the Moon. It's really not very illuminating to say it's 250,000 miles away, because what does that mean? Another way to think about it is that you could fit about 30 Earths between the Earth and the Moon. And the interesting thing is I find people either think that's a lot closer or a lot farther away than they thought the Moon was. And only a few people say, yeah, that sounds about right. So yeah, you can fit 30 Earths between the Earth and the Moon. This was taken, the farthest one, from a distance of only 600,000 miles, but we've gone a lot further. This image is one of those images I shared on social media, and it's the only thing I've shared that really kind of went viral. Because this is an image of the Earth and the Moon taken by the HiRISE camera, which is on board the Mars Reconnaissance Orbiter. So this was an image taken of the Earth and the Moon from orbit of another planet. And that just tells you how good this camera actually is. This is the camera that normally points down and takes pictures of the surface of the Mars. So good that one pixel on that camera is only 1 foot. So if a person laid down on the surface of Mars, it would be able to make you out. I mean, you wore like bright green to make you stand out against the red of the surface. We can see the rovers and the landers and the rover tracks using this camera. But this really shows you how good it is, that it can look back at Earth. It's not even really what you would call a telescope and still make out features on the Earth and see both the Earth and the Moon. So let's keep in mind that Mars is, from this vantage point, 142 million kilometers away when this picture was taken. But this is still not the farthest picture we've ever taken of the Earth and Moon. That goes to the Cassini spacecraft, actually taken a year before that previous image. And this famous image is the day the Earth smiled. To understand what you're seeing, the sun is behind Saturn in this image. So you're looking at that nighttime side of Saturn. And if you look very carefully and follow my pointer here, there's one little dot right here in between a gap in the rings, and that is us. And they told everyone when they were going to take this picture and invited everyone around the world to walk outside, look up, and wave. And you all had your picture taken on that day, even if you didn't know it. And yeah, if you zoom in, the camera is good enough that you can make out both the Earth and the Moon. And so this is indeed the farthest image ever taken of the Moon. And that is where this talk ends. Oh yes, just to tell, 1.44 billion kilometers away. So thank you. I'll take questions now while I put up a pretty video of the Moon.
That showed Neil Armstrong first going down on the moon's surface. Obviously it wasn't all of them because he wasn't out on the surface yet. So how did they do it? And was that camera used for any other shots?
Okay. So I think you're referring to, if I'm hearing you correctly, that there's two different ways we were getting images back. One was using a TV camera, and one was using actual film photography cameras. So the famous footage of Armstrong descending down the ladder, that camera in particular was put on there for that very purpose. It was just there to capture that moment. You can tell by the angle of it. It was actually on an arm that swung out to capture him coming down the ladder. There was another, I think there was a second TV camera on it to actually watch them on the surface of the Moon, if I'm remembering correctly. But then, of course, the pictures I was showing were all of photographs, and that's why they look so much better than that video, because instead of trying to transmit a radio signal back from the Moon, they took those pictures and brought the film back to Earth for development. So they were very beautiful, color, crisp photographs. Let's keep in mind that that first moon landing didn't last very long. I think only a few hours. The most important mission objective there was to show you could do it. In fact, famously, Neil Armstrong shared that, was either Neil or Buzz shared that when they asked, well, what's the most important thing for us to do when we get there? NASA said, get off, because that was the main goal of Apollo 11. So they had a few science experiments, and they, like I said, they were able to take 122 photographs on the surface. But that was what we refer to nowadays more than anything a tech demo, a demonstration that you actually could send humans to the surface. They could do some science on the surface and come back. Later missions were much longer. Later missions did take a lot more pictures, including ones that had far more scientific value. But yeah, so there's those two different methods of taking images, and Apollo 11 was basically just about showing that we could do it. Oh, I see a question in the Q&A, if I can take that, which says, how far was Sagan's, the little blue dot, the pale blue dot image? Yeah, a lot of people bring up like, why isn't that one there? Why did you stop at Saturn? And the answer is because this was a talk about photographing the moon, and the pale blue dot image, you cannot resolve the moon in that. That was taken, I'm trying to remember the distance. It was, I mean, the Saturn picture was about 1.5 billion kilometers. The pale blue dot was taken when it was billions of kilometers away, but I do not know the exact number off the top of my head. I imagine Google could answer that for us very quickly. But yes, that's why I don't go to that image, because you can't actually see the moon in that one. I think, what's it like working for NASA and getting paid for it? Well, I do not actually work for NASA. I work for Cornell, and I work with NASA. I have to say, especially my particular job, where I get to not only like hear about all these cool discoveries, I get to go out and tell everyone about them. Yeah, I sometimes have this like, I can't believe I get paid to just talk to people about cool stuff. I do love my job, and it is pretty awesome that I can make a living out of, just kind of geeking out to other people, because it's, just something I always loved to do. Not necessarily the best for getting you popular at college parties, but makes a living now. I have worked on a NASA mission, still by working for Cornell. When I was a graduate student, I worked on the Spirit and Opportunity missions. And again, it was just the most spectacular experience, because of especially the timing. I graduated high school in 1996. I was in Southern California, so I had visited Jet Propulsion Laboratory, which at that time were in the final building phases of the Pathfinder mission that carried the first ever Mars rover, Sojourner. And so I was very aware of what was going on, very aware that we were returning to Mars after 20 years of not sending landed spacecraft there. And when people would ask me like, well, what are you thinking of like doing with your life? And yeah, I had some ideas, but I would throw out there like, it'd be really cool to work on a mission to Mars. And of course, the reaction you get when you say that, even when you seem to be very talented in science and accomplished, it's kind of like, well, that's awfully specific, and that's a nice goal to shoot for, but not necessarily the most realistic of goals. And yet there I was, only 8 years later. No, 6 years later, I was on a NASA mission to Mars. So yeah, it was definitely a lot of moments of, is this real? Do I actually get to do this? And I just love that it's getting to be an explorer. It's getting to be among first humans to see things and learn things. And like I said, the best part beyond that is getting to go then share it with everyone.
So I'm wondering if you can show the picture of Saturn again and somehow tell us where the Earth and the Moon really were.
Sure. Okay. Sorry about that. It was on my screen, but I guess it didn't come through. So if you look off to it's in the upper left portion of the rings. There's a dot that's just outside of what you would call the main ring system, the big bright rings that are closer to Saturn, before you get to a fainter fuzzy ring. There is a little dot there. So I hope that helps. If someone there sees it, can actually point at the screen for the audience there.
Yes, she just pointed.
All right, we found it. Yay. Yeah, I should put an arrow on there. I realized that because sometimes, yeah, the pointer doesn't come through.
Okay. They're asking about future missions. I don't know if you heard them.
All right, yeah, so that's similar to the question in the Q&A as well. I actually have a whole other talk on the Artemis program and our plans to return to the moon. So, but just very briefly, we of course had Artemis 1 almost a year ago, which was uncrewed. It was basically, they had mechanical mannequins on board and lots of measuring instruments. It went and orbited the moon a few times and basically checking all the systems, making sure that everything would have been safe for humans, that the craft was working as they expected. That was something that they didn't do in Apollo because they didn't have the technological capability of doing an uncrewed mission of that level. We do. Everything was an incredible success. Everything worked beautifully. And so they have selected the Artemis 2 crew for astronauts, and they will be going to the moon, I think late next year or early the fall. So late 2024, early 2025. I think is when they are planned to do their mission. One of the things is we don't have exact dates because we're doing something no one's ever done before, and that means we don't do it until we feel confident that we've got everything and it's safe to do it. And inevitably things come up you didn't expect because of the nature of exploration. And so that can sometimes cause delays. So we don't have an exact date. They'll do it when they know it's good to do. They are not going to land. They are going to basically do the Apollo 8 move of doing a little, figure 8 where they leave the Earth and zip around the moon. They don't actually orbit the moon and they come right back to Earth, but they are going to take a much broader orbit than Apollo 8 or any of the Apollo missions took. So these 4 astronauts will become the farthest humans have ever gotten from the Earth. They will set that new record. And Artemis 3 will probably happen 1.5 to 2 years after that, 1 to 2 years after that, and they will land at the South Pole. They will bring materials to perform tests there. There is the India moon mission right now that became the first spacecraft ever to successfully land at the South Pole of the moon. And it is doing studies right now that they will be sharing with NASA information about the South Pole. And we also will be sending uncrewed missions that will deliver materials for building and establishing that base in between missions so that you don't have to bring everything on the same missions that are bringing astronauts, and that cuts down on costs a lot. So the timeline for when we will have that base established and have it continuously inhabited is definitely within the next 5 years, I would say. We're going to proceed with that as quickly as possible. And it will become something very similar to the International Space Station, where there will always be a crew of astronauts there. They will rotate in and out, but they will be there always doing scientific experiments. And if you want to look up all the things that we have discovered by having laboratories in space, and just anticipate all the other things we're going to discover by having laboratories on the moon. So that is kind of the timeline of the Artemis program, as best as we can predict right now. So I would say in 5 years we will probably have an established moon base.